Good morning, students. I hope that you are fit and fine. In the last period or last lecture, you studied first chapter derivatives. In that chapter, you studied about derivative of given functions, namely first as a derivative of composite function, second as a derivative of parametric function, third as a derivative of trigonometric and inverse trigonometric function, fourth as a derivative of one function with respect to another function, logarithmic differentiation, and derivative of one function with respect to another function. And also you studied how to find out the higher order derivatives of given functions. Now today we have to study about the second chapter, application of the derivatives. In this chapter we have to study about the following subunits. First as a geometrical and physical meaning of derivatives, second as a derivative as a rate measure, third as a approximations, fourth one as a Rolle's theorem and Lagrange's mean value theorem, fifth one is a increasing and decreasing function, and sixth is a maxima and minima, means how to find out the maximum and minimum value of a given function. Now students, you know the derivative has a wide range of applications in everyday life. In this chapter, we shall discuss geometrical and physical significance of the derivatives and some applications. Now first I am starting first unit as a geometrical and physical meaning of a derivatives. Here, for understanding this concept clearly, we have to discuss about the curve. Suppose y is equal to f of x be a continuous function of x. It represent a curve. For better understanding, with the help of drawing, I am here explaining as with the help of figure. Draw the curve y is equal to f of x. On this curve, we have to consider 2 points P and Q. Now, x coordinate of P as A and y coordinate, x coordinate of Q as f of A. Sorry student, it is A plus H. X coordinate of point P as A and x coordinate of Q as A plus H. Then what are the y coordinates of P and Q? Here y coordinate of P as f of A and y coordinate of Q as f of A plus H. Now you have to join these 2 points P and Q. Then you will get a chord PQ. Then how to find out the slope of a chord PQ? Here slope of a chord PQ is equal to f of A plus H minus f of A upon A plus H minus A, then which is equal to f of A plus H minus f of a upon h. Now the point q moves along the curve such that q tends to p. We have to move the q point with the curve in such a way that this point q tends to p. Means here the chord PQ, this chord PQ become as a secant and it approaches at a point P as a tangent. Means you have to draw the tangent this way. Means this PQ become as a tangent at a point P. Then the secant PQ approaches to the tangent at a point P when H becomes the 0. Therefore, a slope of secant PQ, which is equal to a limit as H tends to 0, f of a plus H minus f of a upon H. That is slope of tangent P is equal to f dash of a if limits is exist. Therefore, the derivative of function y is equal to f of x at any point P A B is the slope of a tangent at the point P A B on the curve. Therefore, the slope of tangent at any point is called gradient of the curve y is equal to f of x at point P A B, and it is denoted by dy by dx at P or dy by dx P. Therefore, the equation of tangent to the curve y is equal to f of x at the point, I am here considering point as a generally point x1 y1 is given by given y y minus y1 is equal to m1 into x minus x1, where m1 is a slope of a tangent to the curve at p x1 y1. Similarly, the equation of normal to the curve y is equal to fx at the point p x1 y1 having slope m2 is y minus y1 is equal to m2 into x minus x1. Now students, how to find the slope of a normal? The slope of normal means here at the point px1 y1 slope of a tangent it is given as a m1, then slope of a normal it is a m2. Then how to find out the m2? We know that m1 into m2 is equal to minus 1. Here m1 is the slope of a tangent and m2 is the slope of a normal. But we have to find out the slope of a normal, means m2 is equal to, you have to write minus 1 upon m1. Suppose slope of a tangent m1 is given as minus 2, then how to find out the slope of a normal? You have to take the reciprocal of slope of the tangent, that is a 1 upon 2, and take the sign opposite to the slope of a tangent. Therefore, it is a plus. Therefore, slope of a normal is a 1 by 2. Are you getting, students? Now, means what we have to here find out in a first application. In a first application, you have to find out the equation of tangent as well as the equation of a normal to the given curve. Then a second application as here, second unit as a derivative as a rate measure. What is the meaning of that? Look the students here. In a 11th standard or in a physics, you study that. Here, S is a displacement of a particle at a time t. Then we know that how to find out the velocity. Velocity is nothing but the rate of change of displacement, that is a v. Means displacement at time t you have to find out. Therefore, you have to displacement differentiate with respective time, then you will get the velocity. Then rate of change of velocity, that is a dv by dt. It is nothing but acceleration. Rate of change of velocity, it is nothing but acceleration. That is here d by dt of velocity means ds by dt, which is equal to acceleration. That is here it is d2s by dt square. It is nothing but acceleration. Similarly, here d by dt of acceleration, d by dt of acceleration, it is nothing but jerk, that is a j, it is a jerk. is a jerk. Means you have to write d by dt of acceleration means it is a d2s by dt square, which is equal to d3s by dt3 is equal to jerk, that is a j. It is a including in a syllabus now. Now detail here we have to study if y is equal to f of x be a function, then this function, it is a, in this given function there are two variables x and y. How many variables are there? X and y. Now here the change in x, that is x from x1, from x1 you have to change as x2, and it is denoted by, it is denoted by delta x. That is here in a given function y is equal to f of x, so we have to change in x, that is x1 is changes to x2, means there is a small change, that is a small increments. X1 is changes to x2 and it is denoted by delta x, means you have to write delta x is equal to x2 minus x1, x2 minus x1. Similarly, simultaneously or corresponding changes in a y, that is y changes from y1 to y2 and it is denoted by delta y. Therefore, you have to write delta y is equal to y2 minus y1. Now you have to take the ratio of these two, means you have to write delta y upon delta x is equal to y2 minus y1 upon x2 minus x1. Or you have to write here y2 means what? F of x2 minus f of x1 upon x2 minus x1. It is said to be as the average rate of change with respect to x. With respect to x. Therefore, delta y upon delta x you have to write down as f of x2 minus f of x1 upon x2 minus x1. That is the average rate of change with respect to x. Now, depending upon these two applications, we have to solve some examples. We have to solve some examples. That is, we have to solve the example from the exercise 2.1. Exercise 2.1. Write down first. Find the equation of tangent at pi by 4, comma pi by 2. Of a curve x sine 2y equal to y into cos 2x. Solution. Here equation of curve is, what is given first you have to write down there. Equation of curve is x into sine 2y is equal to y into cos 2x. Point is given as a point, I am writing P, x1 y1 is equal to pi by 4 pi by 2. For finding the equation of tangent at a given point P x1 y1, that is pi by 4 pi by 2, we have to find out the slope of a tangent at that point. Means you have to differentiate this equation of a curve. Therefore you have to differentiate, I am writing it is equation number 1, differentiate equation 1 with respect to x. With respect to x. Look here students, I am writing x sine 2y equal to y into cos 2x. Now students, you studied in a first chapter how to find out the derivative. Here it is a derivative of implicit function. Why? Because we cannot write one variable in terms of another variable. You know that what is the meaning of implicit function? Simply y and x cannot be separated from each other, or one variable cannot be written in terms of another variable. It is the meaning of the implicit function. Then how to differentiate implicit function? You know the students there, here we have to differentiate with respect to x. Where is a y, you have to differentiate with respect to x, and for y terms you have to write into dy by dx. Therefore here on LHS there are two terms in terms of the product. Here is a x and here is a sine 2y. Therefore you have to use here u into v rule or product rule. You know that d by dx of u into v, there it is a u into dv by dx plus v into du by dx. Are you getting students? You have to use the product rule here. Here u means x, v means sine 2y. Then use the product rule. Therefore I am writing here x as it is, u as it is. Find the derivative of v. V is a sine 2y. Look here, I am applying here x as it is into d by dx of sine 2y plus sine 2y as it is into d by dx of x equal to, on RHS also you have to use the product rule, y as it is into d by dx of cos 2x plus cos 2x as it is into d by dx of y. Then x as it is. Then find the derivative of this sine 2y. Here is a y. Then it is a composite function. You have to consider sine 2y as a x. 2y you have to consider as a x. Then this become as a sine x. Therefore derivative of sine x as a cos x. But x means 2y into d by dx of 2y. It is a composite function. Then plus sine 2y derivative of x with respect to x, that is 1, equal to y as it is. It is again a composite function. 2x you have to consider as a x, therefore it become as a cos x. Derivative of cos x, it is a minus sin x, but x means 2x, into d by dx of that function which you have to suppose as a x, plus cos 2x into derivative of y with respect to x, it is a dy by dx. Now x as it is, cos 2y as it is. Here derivative of 2y, y consider as a x, derivative of 2x, it is a 2, and derivative of y as a dy by dx, plus sin 2y equal to minus y into sin 2x into derivative of 2x as a 2 plus cos 2x into dy by dx. Now then after that, in the next step, you have to collect the dy by dx terms there. On LHS, it is 2x into cos 2y into dy by dx. Now from from RHS, you have to write minus cos 2x into dy by dx equal to minus 2y into sin 2x minus sin 2y. Now dy by dx take as a common from LHS. Here 2x cos 2y minus cos 2x, keep in a bracket. I am taking minus as a common from RHS. Here in bracket 2y into sin 2x plus sin 2y plus sin 2y. Then dy by dx is equal to minus, keep in a bracket, 2y sin 2x plus sin 2y upon 2x into cos 2y plus cos 2x. Then dy by dx at the point, what is the point there given? Point is given as a pi by 4, pi by 4. Where is x? You have to write down as a pi by 4, and where is y? Write down as a pi by 2 there. Therefore, which is equal to minus, here write down as a 2, y is a pi by 2, cos 2y, x is there, therefore here is a pi by 4, cos 2, y is a pi by 2, plus sin 2y, y is a pi by 2 upon 2, sorry, here is a pi by 4, here is a pi by 2, and here, okay, 2 x is a pi by 4 cos 2y pi by 2 plus cos 2 x as a pi by 4 equal to, look here again, I am writing as a minus as it is 2, y is a pi by 2, here sine, pen is not working properly, therefore I am jumbling here, 2, x is a pi by 4 plus sine 2, y is a pi by 2, look here, it is a pi by 2, then it is equal to 2 to cancel, it is a minus pi, here sine pi by 2, what is the value of pi by 2? Sine pi by 2 is a 1, I am directly writing here 1 plus 2 to cancel, sine pi it is a 0 upon, it is a pi by 2, 2 to cancel, what is the value of cos pi? It is a 0 plus cos pi by 2, cos pi by 2 it is a 0, sorry, cos a 2 to cancel, cos pi, what is the value of cos pi? It is a minus 1, look here, how to find out cos pi? Cos pi means it is, you have to write cos pi plus 0, then all trigonometric, all silver teacups here, pi up to here, plus is there, therefore angle goes to next quadrant, then it is a even multiple of pi by 2, therefore you have to write cos 0, right? But cos is not in a third quadrant, therefore it is a minus, therefore it is a minus 1, and he is a 0, therefore you have to write minus pi upon minus pi by 2, minus minus plus, therefore dy by dx is equal to, it is a 2. Then the slope of the tangent at a point is a 2 there. Then equation of tangent, you have to write equation of a tangent, therefore you have to write which is equal to the slope of a tangent, slope of tangent, therefore equation of tangent at point P pi by 4 pi by 2 having slope 2 is y minus y1 is equal to m into x minus x1, y minus y1 is a pi by 2 equal to m is a 2, x is a x minus pi by 2. You have to write up to here or you have to calculate there. Therefore, then y minus pi by 2 equal to 2x minus pi by 2. Pi by 2 cancel. Therefore, 2x minus y is equal to 0. It is a equation of a tangent. Then what is the equation of normal? Equation of normal having slope. Having slope. Tell me the children, what is the slope? Here slope of tangent is a 2. Then therefore slope of the normal is a minus 1 by 2. And passing through the point, pi by 4, pi by 2 is, you have to write y minus y1. y1 is a pi by 2 equal to m means the slope of a normal is a 1 by 2, but it is a negative. X minus x1 is a pi by 4. Now you have to calculate that. Simplify that. Simplify. I am multiplying by 2 on both sides. Therefore, it is a 2 into y minus pi by 2 equal to, here, minus 1 into x minus pi by 4. Therefore, it is a 2y minus pi equal to minus x plus pi by 4. Now, x plus 2y equal to pi plus pi by 4, which is equal to 4 pi plus pi. It is a 5 pi by 4. It is a x plus 2y. I have to remove this 4. Therefore, you have to write 4x plus 8y is equal to 5y. It is the equation of a normal. It is the equation of a normal.